So in this video, we will be writing a C program to insert 10 nodes at the beginning of a single linked list. So in the previous video, we saw the algorithm, the steps of inserting a node at the beginning of a single list. Now what we'll do is, we will simulate this part of inserting a node at the beginning of a linked list. How many times? We will do it 10 times because we have to insert 10 nodes. So we'll be writing a function to insert a node at the beginning of a single linked list, and from our main method we'll be calling that function 10 times. Each time we'll be calling the function, a new node will be created. So let's get started. Let's see how we can write this entire program. So I hope you have copied down the question. I'll be erasing the board. So let's start from scratch. So the first thing that we need to do is, so I'll be erasing the board a number of times. So what I would suggest is you pause the video from time to time and you take down whatever I'm writing. So we'll start from the header files, right? So the first header file that we need is, for our printf and scanf, we need the standard input-output header file. So that's stdio.h. Now for our memory management functions, malloc, calloc, realloc, and free, we need the header file stdlib.h. Now after defining the header file, what we need to do is, we need to create a structure. We need to define a structure. What will this structure be used for? This structure will define the node format. So we are dealing with a single linked list. As a result, every node will have two parts. One is the data part, and since we are storing a linked list of integers, our data part will be of type int, and the link part will be of type struct node. So the link part will definitely be a pointer, and it will be a pointer to struct node. Now this is the structure definition. Now after defining the structure, what we'll do is we'll declare the function. So we'll be writing a function to insert a node at the beginning of a single linked list. Now this will be a function that we are writing, so it's a user defined function, and for every user defined function we first need to declare that function. So let's declare the function. So let's call the function insert begin. Let's call the function insert begin, and it will take the head pointer of a linked list as an argument. So it will be struct node star, let's say h, and it will also return a pointer to struct node. So the return type will be struct node star. Just exactly why I'll be passing a pointer to struct node and why I'll be returning a pointer to struct node from this function will be clear to you after I have completed the entire program. So this is my function declaration. Now after declaring the function, what I'll do is I'll start with my main method. So in my main method, what I'll do is I need to create a linked list. Now every linked list, if you remember from my previous videos, every linked list is denoted by its head pointer, right? The starting point of a linked list is how a particular linked list is identified. And how do we denote the starting point of a linked list? We denote the starting point of a linked list through the head pointer. So the first thing that we need to do is, for defining a linked list, we need to create a head pointer. And what will be the type of the pointer? The type of the pointer will definitely be a type of struct node. So the type of head will be struct node star. So I'll say struct node star head. Now initially my linked list will be empty. When I'm starting off with a linked list, it does not contain any nodes. That means the linked list is empty. And how do we denote an empty linked list? We denote an empty linked list by assigning a null value to the head pointer. So what we'll do is we'll assign null to our head pointer. So we assign null to the head pointer. Now we have been asked to create 10 nodes, right? We have to create 10 nodes of a linked list, and we have to do it by calling this function insert begin. We have to call this function how many times? 10 times. And every time I'll be calling this function, a new node will be inserted at the beginning of the list. So in order to create 10 nodes, I'll be running a loop. So for my loop, I need a variable, a loop control variable. I'm calling it I. Okay. So now what I'll do is, now I'll start with the loop. So my loop will have to run 10 times. So let's say my loop starts from 1 and it goes up to 10. That means that this loop will run how many times? This loop will run 10 times, right? So this is the initialization, this is your test condition, and this is the updation. So every time this loop will run, so what will I write in the body? Every time the loop runs, I'll be calling this function. So let's call this function. So this function, let me call this function. How do I call a function? I write the name of the function. That's the first thing that I do. I write the name of the function and I see from the function declaration that whether the function expects any argument. I can see that this function expects an argument and that argument is a pointer to struct node. So this pointer that I'll be passing is, this will be the linked list. And how do I pass an entire linked list to a function? I pass an entire linked list to a function by passing the head. By passing the head of the linked list, I am able to pass the entire linked list to a function. So here I'll be passing the head pointer. And now this function will make the necessary modifications on the linked list that I have passed as an argument. And since I want those modifications to be reflected back in my original linked list, I want the return value of this function to be stored in head itself. So I'll say head to capture the return value. So what this will do is, this loop will run 10 times, and for every iteration of the loop, this function will be called and my linked list will be created. So this will bring an end to my main method. Okay. So I've written down the main method. Now after this, I'll simply write return 0. And this will bring an end to the main method. So what I would suggest is you pause the video and copy this down. I'll move on to defining my insert begin function. Okay. Let's start defining the function now. So the name of the function was insert begin. So the name of the function was insert begin, and it is expecting a pointer to struct node as an argument. So I'll write struct node star head, and it is also returning a pointer to struct node. So it will be struct node star as the return type, right? Okay. Now what I'll do is, I'll now move on to creating the linked list, right? Creating a node one after the other. And how do I create the node? I'll create the node by inserting a node. I'll create the linked list, right? I'll create the linked list by inserting a node at the beginning of the list. So now what is the first possibility? It may so happen that this function is called for the very first time. If this function is called for the very first time, what does it indicate? It indicates that my linked list is currently empty, right? If this function is called on an empty linked list, then what do I have to do? I have to create a single node, and a linked list with a single node is the first node as well as the last node. So I need to set the link part of this node, the first node that I create, to null. And I also need to make its address pointed to by my h, because a first node, an only node in a linked list is the first node as well as the last node. Now what is the feature of the first node? The first node, the address of the first node rather, is contained in the head pointer, and what is the feature of the last node? The link part of the last node contains null. So first thing that I need to check is if my list is empty or not. So how do I do that? I say if h is equal to null. So an empty list, how do you denote an empty list? Just like we saw in our main method, that the head should be null. So if the head is null, then what do I need to do? I'll have to create the first node of my linked list. So how to create a node? So I create a node using malloc. So I write struct node star, and then I write malloc. And what should be the size of the node? It should be the same as the size of my structure. So it should be size of struct node, right? Now since malloc returns a void pointer, I need to typecast it to struct node star. Why struct node star? Because look at the type of H. The type of H is struct node star. So this will create a single node. Now after creating the node, what do I need to do? I need to give it a value. And now, how do I get the value? I'll ask the user for the value, right? So I'll ask the user, enter value of node. Enter value of node. Now, this will be stored in the data part of the node to which H is currently pointing. And since it is also my last node, a linked list with a single node is the first node as well as the last node. Now, since it is the first node, it is being pointed to by H, my head, and since it is the last node, its link part should be null. Like, I cannot emphasize on this point enough that a linked list with a single node is the first node as well as the last node. This is very important for you to understand in order to be able to write proper linked list programs, because you have to take into consideration all possible cases. So this is the first case that we consider. Now our linked list is complete. So okay, I have missed an ampersand here, so it should be scanf. Yeah, that's better. So it's ampersand H arrow data, and yeah, so this creates a node when the linked list is completely empty. Now what if H is not equal to null? What if this condition is not satisfied? If this condition is not satisfied, that means my linked list contains one or more nodes. Now if the linked list contains one or more nodes, what I need to do is I need to insert a new node at the beginning of the already created linked list. So how do we do that? So we need the help of another pointer now. So we need to declare another pointer of type struct node. So I'll say struct node star PTR. And now using PTR, I'll create a new node. How do I create a new node? I create a new node using malloc. And malloc will accept the size of the node. So I say size of, sorry about that. So I say size of struct node. And what will malloc return? Malloc will return a void pointer. So I need to typecast it to the appropriate type. So the appropriate type in this case is struct node star. Now after doing this, what I need to do is I need to accept the value of the node. So I'll accept the value of the node from the user. So I'll ask the user, just like I asked here, to enter the value of the node. So I'll say enter value of node. Now on seeing this statement, the user will enter a value, and that value has to be stored in the data part of the node to which PTR is pointing, because this is my newly created node, right? Now the node is ready. The node is complete. Its data part has been filled up. Now we have to link this node to our already existing linked list. So how do we do that? We say that the link part of this newly created node, since this newly created node will be my first node, this newly created node will be the new first node of my linked list. It should now point to the already existing first node of the linked list. See, I already have a linked list with me, right? Let's say I already have a linked list with me. Let's say I have a linked list with 3 nodes. So this linked list already exists and it is pointed to by H. Now I already have created a new node. Now that new node is being now pointed to by PTR. Now if this new node has to become the first node of my linked list, it should first point to the originally existing linked list. So how do I make this connection? So I say PTR arrow link is equal to, how do I identify the first node of my already existing list? I identify the first node of the already existing list through the head pointer. So I write PTR arrow link equal to H. And now since this is my new first node, H should point to it. So I should write H is equal to, how do I access this node? This node can be identified through PTR. So I should say H is equal to PTR. Now H will no longer point to this node, instead it will point to this node because this is the newly created node which is also the first node of my linked list. Now after doing all this, what I need to do is I need to ensure that the changes that I've made on the linked list that was passed to this function, those changes are reflected back in the main method. So how do I do that? I need to return the head pointer. So if I return the head pointer, then the newly formed linked list will be reflected in the original function. So I say return H, and this will bring an end to my function. Right. Now what I'll do is I'll do the dry run of this program. So that will help to clear a lot of doubts. So let's see how the dry run goes about. So what I suggest is you pause the video and you copy this down, and then I can proceed to the dry run. Now let's do the dry run. Okay. So where does the program execution start from? The program execution always starts from the main method. Okay. So if you remember the first line of the main method, so I'll go line by line. I'll start right from the first line of main. So what I would suggest is you follow along. See, I don't have the entire program on the board written with me. You have it probably in your copy. So you follow along with me. I'll be starting right from the first line of the main method because main denotes the starting point of execution. So what is the first line telling me? The first line is telling me that I have a variable called head and it gets a value of null. So head currently has a value of null. And I have declared, I think, another variable called I. I haven't given it any value so far. So its value is unknown. So I don't know its value. And next what I've done is I have tried to start a loop, right? If you follow along with the program, you will see that I've started with a loop. Now, how do I start the loop? See, I have started with an initial value of 1. So I is starting off with an initial value of 1. And now what is the condition? The condition was something like this. I lesser than or equal to 10. So what is the value of I right now? The value of I is 1. Is 1 less than equal to 10? Yes, the condition is satisfied. Now I'll come inside the body of the loop. Now in the body of the loop, you will find that I have called the function insert begin. So I've called the function insert begin and I have passed the value of head. What is the current value of head? The current value of head is null. So I'm passing a value of null and this function will return a value and that return value will be stored in head itself. Now when I will pass the value of null, if you look at the function definition, see, this statement will cause the control to be transferred to the function definition of insert begin. So now I'll look at the function definition of insert begin and there I find that this null value is copied to h. So my h in my insert begin function currently has a value of null. So now if you look at that function, now I am inside the insert begin function. See, this is the main method. This is the main method and this is the, let's say I have the insert begin method. So this is the insert begin method. Now in the insert begin method, my h, so I'll show it separately, okay. Now this null value, so insert begin is expecting an argument. Now this null value will be stored in h. So now h contains null. H contains null. I think I have declared another pointer called ptr. So ptr currently contains nothing. So ptr's value is unknown. Now if you look at that function, there is a if condition. What is the if condition? If h is equal to null. Is the condition satisfied? Yes, the condition is satisfied because h is currently equal to null. So you'll come inside and then what you'll do is through h you'll be creating a pointer. Through h you'll be creating a node. So h will now point to a block. H will now point to a block. Now this block will have two parts. It's the same as the node format which we defined earlier. So now h is pointing to a block. Now you will ask the user for a value. Let's say the user enters 20. So this is the data part. This is the data part and this is the link part. See, this is the data part and this is the link part. And when I say h arrow data, that means take the user value and put it in this part. So let's say the user enters 20. So h arrow data gets 20. Now I say h arrow link equal to null. So this part will become null. See, this is the only node in my linked list so far. Now after doing this, what I do is I come out of the if part. Now after I come out of the if part, obviously out of the if and else, if the if part is executed, the else part will no longer be executed. And after coming out of the if block, I'll directly go to return h. So let's say this node has a starting address of 1000, and that means h has a value of 1000. So last statement is return h. So this value of 1000 will now be returned to head. That means head will now point to this node. So head currently points to this node and it has a value of 1000. And now see, since h was a local variable, see h, the variable h, its existence is only inside the insert begin function. So after this function returns, h will be destroyed. That means after returning the value, h has no existence, and this linked list which I've just created with one node is being currently pointed to by head only. By head only. So this comes to an end. Right? Let's take another run. Now the value of I will be updated from 1 to 2, and then you will check the condition. Is 2 less than or equal to 10? Yes, it is. So you come inside the loop and again you invoke this function. Now what will you invoke this function with? You will invoke this function with the current value of head. So you will be passing the value of head, right? And what is the current value of head right now? See, the current value of head is no longer null. It's this value of 1000. So head currently has a value of 1000. So you'll be invoking this function with 1000. Now when you pass 1000, now h will also be pointing to this node because h has received this value of 1000. So h also points to this node. Now the question is, how do you go about? Now in this case, what will happen is the if condition will not be satisfied. Why? Because the current value of h is 1000. Current value of h is 1000. So the if condition is not satisfied. You will come to the else part. And in the else part, using ptr, you will create a new node. Let's say the address of this node is 200. So ptr currently contains 200. ptr, just like h, is another local variable. Now this node has two parts. Now you ask the user for the value of the node, and let's say the user enters 10. Now after the user enters 10, what you do is you put that value in the node that is being pointed to by ptr. So ptr is pointing to this node. The data part of this node gets a value of 10. Now what do? You take this node and you try to link it with the already existing linked list. So how do you do that? You say ptr arrow link equal to h. So now this node will point to this node. Now after you do this, this becomes your new first node. Since this becomes the new first node, h needs to point to it. So what you do is you say h is equal to ptr. What is the value of ptr? 200. What is the value of h? 1000. So h becomes 200 right now. As a result, it no longer points to this node. It now points to your newly created node, which is also the first node of my list. Now after doing this, you come out of the else block and you say return h. So return h means this 200 will now be given to head. Now head will contain 200. That means head no longer contains 1000. Head contains 200. Head contains 200 and it is pointing to the first node. It is pointing to the first node. And since h was a local variable, its existence is no longer there. After the value is returned, h is destroyed. H is destroyed. Similarly, since ptr was a local variable, ptr was created inside insert begin function, it will also be destroyed once insert begin returns. So this is your linked list after 2 iterations of the for loop. Let's take one more iteration. Now, I becomes 3. The condition is satisfied, so you come inside the loop. And you again call the function by passing the argument of head itself. So what is the current value of head? The current value of head is 200. So you pass the value of 200. Now this 200 goes inside h. So h is now containing 200 and it is pointing to this node. Since h is pointing to this node, your function, your insert begin function starts with a check whether h is equal to null or not. Obviously, h is not equal to null, so it comes to the else part. In the else part, you create a new node. You create a new node using ptr. Let's say the address of this node is 30. Now, ptr contains 30. So ptr is pointing to this node. This node has two parts, a data part and a link part. You ask the user for the value of the node, and in the data part of the node that is being pointed to by ptr, you stored that value. Let's say the user enters 1. Okay, and after this, what you want to do is you want to link this newly created node to your already existing linked list. How do you do that? You need to connect this. So how do you do that? How do you access this part? This is the link part that is being pointed to by ptr. So you say ptr arrow link. Ptr arrow link means access the link part of the node. Access the link part of the node that is being pointed to by ptr. That means this part, and give it a value of h. So the value of h is how much? The value of h is 200. So this gets a value of 200. Now it is pointing to your previous first node. Now after this node is created, it is the new first node. The previous first node was this one whose address was 200. So it should point to this. And one more thing that I should do is I should make h point to this node. Why? Because this is the newly created first node. So h should now become same as ptr. So I write h equal to ptr. So if I say h equal to ptr, then h gets a value of 30. So h is no longer pointing to this node. H is now pointing to this node. Now after this, what I do, I come out of the else block and I say return h. So when I say return h, the value of h, which is 30, is stored inside head. So head now becomes 30. Head becomes 30. So head is no longer pointing to this node. It is now pointing to this node. So head now becomes 30 and it is pointing to this node. And since h was a local variable, after the function returns, its existence is no longer there. Its existence is no longer there. And similarly, since ptr was a local variable, its existence is no longer there after the function returns. So in this way, the loop will continue, right? And this link part contains what? This link part contains 1000. That is why it is pointing to it. So see, every time this function is being called, a new node is being inserted at the beginning of the linked list. Now, this thing will continue. So next, your I will become 4. Your I will become 4 and you will pass the current value of head. What is the current value of head? 30. And in this way, another node will be created at the beginning of the linked list. So this will go on. How many times? 10 times. And every time the loop runs, this function will be called and a new node will be inserted at the beginning of the list. So what kind of a question will be asked in your examination? In your examination, you will be asked to write a function to insert a node at the beginning of the linked list. When you're asked to write a function to insert a node at the beginning of the linked list, you do not need to write the entire program. You only need to write the insert begin function. Whatever I have shown you, you need to write that part only. No need of writing the entire program. That part will be sufficient. And before writing the function, you should define the structure. The struct node part, which I wrote at the beginning, that should be there, and that should be followed by your insert begin function definition. Okay, so I hope this helps. What I would suggest is, if you do not get it at the first attempt, you watch this video 2 or 3 times. It is a bit lengthy, I know, but once you get the catch of this video, you will be able to understand all linked list functions. And if you have any doubts, please feel free to comment in the section given below. I hope this helps. Thank you so very much.